The other thing too is, so the last two classes, for some reason, the recordings were corrupt. I was able to get them loading now, so I can link them. I know that's not going to be a big help for a lot of you because you've gone through the assignment, but if you're redoing the assignment, then you'll be able to at least go back and watch this video and see maybe where some things are helpful. I now know what's going on, so this recording I'll be able to put up pretty quickly, so that way everyone can go back and take a look at it, as they're doing their homework. So let's go back to the screen share. All right, so in this module, we are talking about chapter 4. Remember what I said last week, which is, as a developer, like there's these big pivotal points in what it takes to be, feel like a developer. So you need to be able to do variables. You need to be able to, and when I shouldn't say variables, really the big number one is to be able to output data, right? And input data. So asking a user for information, outputting information, and that kind of ties all together with variables, because a program without variables is nothing more than a script that's going to just do the same thing over and over again. It gives very little value to anyone. We always need data. It's the variance of the data that makes our programs actually feel like there's value to them. If your calculator always added 1 and 2 together, you're not going to get that far. The fact that you can put in different numbers is why the calculator is valuable. And so input and variables is that number one step. Number 2 step is the if statements, the if, else if, and the else statements. So being able to create logical direction for your code is kind of that second phase. So we can say, okay, do something here under this condition, but don't do it under this condition. That logical gateway is that number 2. And now we're going to talk about that number 3 piece, which is oftentimes we want to repeat similar code over and over again. For example, if we've got a table of data, we may want to iterate through that table and we want to add pieces of that information or just display it on the screen row by row by row. Oftentimes, we take data, we'll do some manipulation row by row. We'll show what we brought back from the database plus what we've now manipulated. And so again, we're sitting in what's known as a loop to do that. So imagine if you had to program the same piece of code over and over and over again to get something accomplished. Well, one, you're very limited because what if you don't know how big your loop should be or how many times you should copy and paste that code? Maybe it should change every single time. So as you can see, we've run into really quickly bad scenarios that without something like what we're going to talk about today, which is the while loop and the for loop, you don't have any real recourse to doing that looping or that ability to use the same code over and over as many times as you need or as little as you need. So that's what we're going to talk about this week. And like I said, those are the big, at least in my mind, the big 3 that once you get this down pat, you're going to really feel like you can write you're going to feel like you can write any kind of code you want because those are the big 3 functions. Now, beyond that, there's a lot of little things here and there that we're going to pick up in the rest of the semester that's going to just help expand on these 3 big items. In fact, we're going to talk about a couple of those items even in this module. So let's go ahead and jump in and get started. By the way, these 3 big items is pretty similar in all languages, whether you're programming in C#, C++, older languages like Perl, classic ASP, all the way up to advanced JavaScript. These 3 functions are oftentimes the biggest components. All right. So let's go ahead and talk about the introduction to that repetitive structures. So again, this is the for loops. Come on in. Okay.
I'm sorry.
It's okay. All right, so that introduction to repetitive structures. So again, we don't want to write code more than once. One, if you start doing that and you need to make a change to your code, now you have to go through your code and make that changes how many ever times you've repeated this code. So I will tell you, one of the biggest no-nos is try to avoid repeating code, especially exactly the same code. We even try to stop repeating similar code. Again, similar code, oftentimes we can use variables to change that up just enough to where we can put it into something that is repetitive. So with repetitive structures, we're talking about makes computers repeat included code as necessary. And we're going to do that with condition controlled loops and count controlled loops. Those are the two big items that we're going to talk about tonight. So a condition controlled loop, also known, AKA one of them is the while loop. There are some other ones, but the while loop is the first one we're going to talk about. And some things to know about the while loop. First off is the general format is the word while, which is the keyword, and then a condition, and then the colon. Under that and indented are the statements that you want to repeat as long as the condition is true. So that kind of goes up to that top part, which is the condition tested for true or false value, and then the statements that are repeated as long as that condition is true. In a flowchart, lines go back to previous parts. So we can kind of look at that by looking at this condition controlled loop flowchart. We have a condition that's always going to be evaluated, and it's going, if it's true, then it's going to run the statements, come back up and retest the condition. Again, if it's true, it'll do the statements again. If it's at any time it becomes false, it will stop doing those statements. That way I can see if anyone raises their hand or anything, I can see. So in order for the loop to stop executing, something in the code, in the actual loop itself, has to change what's going to happen in that condition up there at the top of the while loop. If you don't change that code, if it always stays true, you'll have what's known as an infinite loop. And we'll talk, they talk about it a little bit in a few more slides. But for the most part, it's a loop that just never stops. And there are good reasons to have that. You know, right away, most people think, oh, infinite loop, we don't want to do that. And for the most part, probably don't. But there are reasons that an infinite loop is a good idea. For example, if you're writing code for a soda machine, that's an infinite loop. It's waiting for you to put money in. It's going to dispense your product. It's going to make sure that you get your change, and then it's going to go back to the top. And really, the only way to break that loop is to unplug it. Otherwise, that's the loop. That's what it's designed for. So it's an infinite loop, and it will continue to be an infinite loop. We write programs in the industry all the time that are infinite loops, because that's the point of them, is they continue to do the same thing over and over again, day in, day out, and there's a purpose behind that. Each time we do one of our loops, we go through the loop, it's known as an iteration. You'll hear that word quite a bit, and you'll hear the root of that word, which is iterate, quite a bit as well. Iteration is one execution of the loop. Now, a while loop is known as what's known as a pre-test loop, and that's because the condition's always going to be tested first before the code is done. There are other types of loops where it will do the loop portion first and then test, but not this one. This is known as a pre-test. What's nice about the pre-test is that you know that you don't have to necessarily, the code doesn't have to go into the loop the very first time. You may not have a condition where the loop should start up and start going. That can happen with a pre-test loop. And one of the things, and this is what they're saying by it requires performing some steps prior to the loop. This is known as loop priming. We have to prime the loop on pre-test condition controlled loops because that condition isn't set to anything yet. So we have to prime it first. We have to set that condition to true for the very first time for it to go into the code. And remember what I said was your code in the loop should change your condition to stop the loop, right? Well, before you go into that loop, you have to first set the condition to true if you want it to even go into the loop to then continue to change or at some point change the condition to false to stop the loop. Does that make sense? So that's known as priming the loop. And we're going to see some of that today when we go through some things. So here we have an example of a flowchart with a while loop. Let me blow it up. All right. So we can see in here it says assign y to the variable keep going. That's the priming of the loop. That's where we're setting that condition up to be successful the very first time, so it will even go into the loop. Now, again, let's say we're using this for something we're going to talk about here in a moment, where you're using a loop for a user to input data. What if the user starts that program up and goes, oh, I don't even really want this to run? They may not put the data that they're supposed to keep it running. Maybe they hit the enter key right away, which is going to stop the for loop. It will never, excuse me, the while loop, it'll never go into that while loop because they didn't hit the enter. They hit enter the first time. So there's an example of how sometimes we don't even go into a loop. Maybe we pull data and we find that there's no rows of data. Well, then if there's no rows of data, don't go into the while loop. So there's some examples, but that's the priming of the loop by assigning y to keep it going. Once we've done that, the first thing that happens is we go into the condition part of the while statement and we look for, is this a y? If it is, then we're going to go through these things where we're going to prompt the user to enter the amount of sales and assign it to the sales. Now remember, so far nothing really has happened until we've gone into this loop. Next, we're going to prompt the user to enter their commission rate and assign it to the commission rate. Then we're going to take the commission sales, times it by the commission rate, display the commission, and then prompt the user, do you want to calculate another commission? Enter Y for yes, and assign the input, enter Y for yes. And if they do, then we will keep the keep going variable as Y. If they enter something other than Y, then we're going to change that keep going variable to something other than Y. And that means when we come back up here and go back into the condition, we'll be able to stop the loop if they don't have it as a Y anymore. All right. So we talked a little bit about the infinite loops. You know, again, loops must contain within themselves a way to terminate. That's the key, is in the actual loop, there has to be a way to terminate the loop. Now, I'm saying that because we're in Python. Other languages, you could have multiple threads running, and you could, one thread could set the flag variable to something that the other thread picks up. And so in that case, not necessarily, but here in Python, what we're talking about, what we're doing, your code that's in the actual loop somehow has to change the condition to be false to come out of the loop. If you don't, you get that infinite loop. And that's that loop that does not have a way of stopping. It repeats until program is interrupted, occurs when programmer forgets to include stopping code in the loop. Now, with that said, let's go back to our previous example where this person is prompt the user to enter the amount of sales and assign it to sales, prompt the user to enter the commission rate and assign it to commission rate. What if we were making a computer program that was going to go on a rather simple computer that was designed to, that's all this computer is going to be assigned for. It's going to sit on someone's desk. And when someone has a sale, they're going to come in, they're going to enter this information in and be done with it. Well, in that case, then maybe we don't ever allow the code to stop, right? Maybe we say, hey, this computer is meant to stay on forever and the rest of its life. And so we don't want to put the ability to stop this code. Then we've got that infinite loop that we've been talking about, which is the code just keeps going and going and going.
Okay, back. I think I'll be not leaving.
Okay. It's okay. All right. So we've talked about the while loop. Let's take a moment just to take a look at the while loop. So we're going to create a new file. And we are going to simply do what that kind of that program was doing in our example here. Let's blow that back up. Okay, so we'll try to put this off a little bit to the side. So the first thing we're going to do, and so we can start getting used to it for those that aren't used to it, let's go ahead and define main. And later, we're going to go ahead and come right down here, and we're actually going to now call main. Because believe it or not, if you don't do that, you may sit there, especially if you're really tired, and you keep trying to run your code and nothing's happening, and you're like, why? And then all of a sudden you finally realize that while you did a great job of defining your main, you never actually called your main. Trust me, it happens. And then, you know, it's just one of those things when you're really tired, it happens. Okay, so the first thing we're going to do is assign prime var. So this is that priming the loop. And we're going to say keep going equals y. Now, since we're getting into this, I'm going to make a small set of modifications to the program because I want to show you what it looks like, something that you would see more commonly in the industry. More in the industry, we wouldn't necessarily use a conditional flag that's letter-based. We oftentimes would use it as Boolean-based or integer-based, right? So we're going to go ahead and say keep going is 1. Okay. And then the first thing we're going to do is we're going to jump right into our while loop. And we're going to ask while keep going equals 1. Make sure you put your colon there so that way it automatically indents for us. And now it says prompt the user to enter the amount of sales and assign it to sales. And just so we can keep things a little short. Now we're going to prompt the user to enter the commission rate and assign it to commission rate. Then our next instruction is commission equals sales times commission rate. We use an F string. Sorry. So now we're displaying the commission. And then we're going to say yep, so I'm doing that right now. Oops, sorry. Now, what happened here was, again, this code, the way they have it over here is they could really take the user input right away and utilize it for the keep going variable up here. Because I've switched it over to a 0 or a 1, I have to actually use an if statement that says, hey, if the user's input is anything but a Y, then make the keep going no longer true. And that's, again, in the industry, again, we typically would do it this way because we still want to, we don't actually want to use 1 or 0 here because that doesn't make sense to a user oftentimes. So we'll still keep it as Y or N, but behind the scenes to make it a little bit more programmatically correct, more readable, we oftentimes will use something like a Boolean value like a 0 or a 1. All right, let's see this. Let's run. Let's get all my syntax errors out of the way. quite sure why it's not liking that. Let's just make sure. Sometimes, again, all right, well, you know what? I don't want to get too caught up in why this is not. Now I feel like I'm Microsoft doing a demo. Hmm. So here you go. Now you get to see the fun of trying to figure out what's going on. Okay. So let's now. So again, now you get to see what it looks like to literally kind of pull this apart and see what's going on. So what we're doing now is we're going to go line by line. Say again. So on this line, so you're saying change this F? I mean, no, this should work, but you know what we can do? We can let's add first this piece. So far, so good. So we think that this might be the problem. To see how this is a good example of how to debug something like this, I'm literally just pulling it line by line in. There you go. So there is the problem. Oh. See? One small little simple thing. You see all what was wrong? I, for whatever reason, put a comma here instead of a colon. So now this should work. Okay, inner sales. So we sold $100 and we get 5%. So our commission rate is $5. Keep going, yes or no? Why? So now we sold 24,000. And we get the beautiful 4%. So there's our commission. Now, because I said in my if statement, look for anything that's not a Y, because even though I tried to be nice to my my users and help them understand that I'm looking for a yes or no, it doesn't matter if they type in W, it's going to stop because I'm really looking for that Y. All right. So here's a good example of a while statement. All right. Now the for loop is a count controlled loop. So in this, we are going to continue a loop for a predetermined number of times. And when I say predetermined, I mean only at minimum at the point of when we define the for loop. So we can use variables to help our for loop and define what that looks like. So it can be different each time it runs. But when we actually specify the for, we have to tell the for loop how many times we want to run this. So the general format is this: the keyword for, the variable, which is known as the target variable, and we'll talk about that here in a moment, in, and then this has to be an iterative or an iteration of data or a sequence of data. Now we can do that with we can physically put the square brackets and list out the data, which I'll show you here in a moment. Or we can use a function that's going to create an iterative object for us. So let's do it by hand. By the way, real quick, that target variable is the variable which the target is assigned. So as it's going through these values, it's going to take whatever value it's currently on and assign it in the target variable for us to use if we wish to. So here we go. For num in 1, 2, 3, 4, 5. Because it's square brackets, it means it's an array, it's an iterative object. And so we can go through each one of these numbers. The first iteration, we're going to take the 1 and put it into num. So this code would print 1. Now on the second iteration, it's going to grab the 2 and put it in num. So this would print 2, and so forth and so on. 3, then 4, then 5. And then it would stop doing this because it's ran through the iterative object, which is the 1, 2, 3, 4, 5. Sorry. So this is great that we can do the 1, 2, 3, 4, 5 in square brackets, but it's not very practical. It doesn't help us a lot. It's not going to be really what we want to use because, again, now we have predetermined ahead of time what this loop should do. More than likely, we're going to want to use variables. So to produce that iterable sequence, we can use a function called range. And we're going to use the range a lot when it comes to the for loop. Now that range function, it just simply takes some variables in and then behind the scenes creates this iterable object. So it's a sequence of values. The range takes 3 arguments. The first one is, it can take up to 3 variables. If it has arguments, if it only has 1 argument, then it's used as the ending limit and it will start at 0. I believe it starts at 0. We'll have to check that. Some languages start at 1, some languages start at 0. I have to remember. I believe Python starts at 0, but we'll check that out. So if we just use 1 argument, it's going to be the end limit. So this is going to iterate through, starting with that number that I just told you, 0, 1, and then go through to the ending limit. If you use 2 arguments, then the first argument is the starting value, and the second one is the ending value, and it's going to do it using 1 as its step. So if you put 1 and 5, 1 is the first argument and 5 is the second argument, it will change that to 1, 2, 3, 4, 5. Finally, the third argument, if you utilize that, is the step value. So if you say, let's say your starting value is 1 and your end value is 10, then but your step value is 2, then what will happen is it will go 1, 3, 5, 7, 9, and then stop, because you said 10 was the limit. So the step is how many steps will it take while it's making that iteration. So using the target variable, so let's take a moment actually before we go on any further and just simply show some examples of that. What we want to see yet. So I was right. Python does use 0 as its starting number if you have not specified, if you only use 1 parameter. Right. So we're going to say for count and range. And let's start with 0, go to 100, and then we're going to use steps by 5. Now, one of the things we haven't talked about is on the next slide. So let me go ahead and talk about that. Is using that target variable, we can use that inside of our loop. And we can use it for anything that we want, for calculations, for printing purposes, you name it. It's a variable that's that you can use within the loop. So we're going to use it as what we're going to print out. So there we go. It looped through this, printing out the count. Behind the scenes, range turned this into 0, 5, 0, 5, 10, 5, 10, 15, 20, so forth and so on until it got to 100. Everyone still with me?
Yeah.
So with that, letting the user control the loop iterations. Sometimes the programmer does not know exactly how many times the loop will execute, and that's where we can start to utilize variables in our for loop. So maybe we say, so we're going to change our for loop this time. Now we're going to put some variables in. And we're going to let it do a step range of 1 by getting rid of that third parameter. So what does that look like? So what is the start number? Let's do 0 to 50. That's how we can make this for loop a little bit more dynamic. We can utilize variables within it. And because we like to have fun, we can also I think we did last time 0, we did 100, we did it by 5. There we go. By the way, hint, 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 this is very similar to something you have to do in your homework. I thank you, Professor. You don't have to actually thank me. I like to add my own little commentary. We can go backwards, by the way, in ranges. We can start with the high number and go backwards. And that is something that when you're out in the programming world, 1, I'll say it doesn't happen often. 2, I will say that more times than not, it usually leads to disaster, but it is doable, right? And the reason why it oftentimes leads to disaster is because data is usually sequential. The way we view the world is usually sequential. And so what happens is when you start going backwards, I've seen people do things like they'll start going backwards and they'll start deleting data, but because they're going backwards, it resets the counting system in the data. And so they start to erase data they didn't mean to erase. Little things like that. It's really hard. I should have came prepared with a better example. But again, we can do it. Just remember that you're going to find that it doesn't happen often and it can become disastrous pretty quickly. So let's go ahead and re-implement this, but using a negative step. So we're going to run this again. But instead of our first number being the low number and our second number being the high number, we're going to reverse that. So we're going to say 100. And we're going to then say the end number is a 0. And this time we're going to use a negative number as the step. This way we go backwards. Now, again, for that, what you're seeing here, what I just in effect did was do this. Okay, so with that being said, and I've already given you the warnings, why might we do that? But what if we wanted to go backwards? What if we're doing a countdown? What if we are doing something with data? Even my last name, right, is Waits. And so I like it when they do attendance backwards because then I get to get called first and then I can doze the rest of the time. So there are definitely reasons to go backwards. And so just wanted to show you that. It's one of the slides that we have. And there you go. Any questions about that? That is the ranges from highest to lowest, creating an iterable sequence that's backwards, basically. All right, now we're going to step away from the idea of looping for a moment. In fact, why don't we go ahead and before we continue on, it's 7 o'clock, it's the top of the hour. So why don't we go ahead and take a 15-minute break and then we'll come back and we will jump into the next portion of this module. So I'll see you all back at 7:15. All right, we can get back and get started. Let's get the screen share going. And with the def main, I see that you're saying that you had a ton of trouble the other day. Again, make sure you, if you're having trouble with def main, spend a little bit of time with it. If you're still having trouble with it, shoot it over to me to take a look at. Like I was saying to one of the students here in class, the number one issue is usually tabbing. And then the second issue is usually a forgotten if, a colon. So make sure you have your little colon here, otherwise you will have issues. Okay, so let's jump in and talk about calculating a running total. Again, when we're doing a loop, oftentimes that's exactly why we're doing a loop. We want to do some kind of math calculation. Oftentimes we are trying to calculate a running total. So when we do that, we are going to assign a variable that's called an accumulator. It's just a fancy word for a variable that we're going to use inside of our loop that will continue to increment or decrement depending on what we're trying to do, whether we're adding values or subtracting values. So this accumulator variable is created before the loop, and then it's utilized in the loop. And it's important to know that you have to create that variable before the loop, because if you create it in the loop, it recreates every single time the iteration happens, thus kind of doing away with what you want to do. So make sure you are putting that accumulator before the loop and then utilizing it in the loop. So if we go back to our example, we can set up that accumulator And we're going to go ahead and assign it 0 to get it started. And then we are going to say running total equals, and because it's an accumulator, we have to say running total again, because we're going to take the running total, we're going to add whatever we want to add to it. In this case, we're just going to add the target variable to the running total. So in this case, the first time this goes through, we have a 0, 100, and then 5. The first number going through would be 0. So 0 plus 0 is going to be 0. The next time it's going to be, the count's going to be 5. So it's 0 plus 5, which now makes running total a 5. The next time through, count's going to be 10. So it's going to say this variable is now going to equal 5 plus 10. Now we have that makes it 15. And then 15 plus so forth and so on, right? But now that we've done that, when we come out of the loop, we want to give that total variable, right? So print f now, to be frank with you, I mean, we could also make it as part of our loop. Just every time it iterates, it's going to give us that total and that incrementing total. So that doesn't happen all that often. So we're not going to do it right now. We're going to go ahead and just do it in the standard way we would normally do it. So let's go ahead and do our 0, our 100, and our 5. And if you were to take all these numbers and add them up together, it comes out to 950. All right. So this is just a flow chart of what we just did. We set the accumulator to 0. Then we went into the loop. We read the next number, or created the next number, and then we added that number to the accumulator. Now, what they're not showing in this is at the end, when we break out of the loop, we go ahead and print out the accumulator. We do something with that accumulator, whether we write it back to the database, we output it to the user, we're doing something with it, right? And that's something that they didn't really show here, but we just printed it out to the screen. Now, take a look at what we had here. This was, sorry, not that one. This was the running total equals running total plus count. Keep that in mind here as we go through the next couple slides. So in many assignment statements, the variable on the left side of the operator can also appear on the right side of the operator. That's exactly what we just did. Well, when we do that, we can have what's known as these augmented assignment operators. It's a special set of operators designed for this type of mathematics. And that is basically, we are going to do something to a variable and assign that result back to the variable itself. So with that, we have these shorthand operators. So for example, on the way on the right here, if we wanted to say x equals x plus 5, which is kind of what we did, we could shorten it by using the plus equal sign. And we just say x plus equals 5. That tells our Python that we mean to take whatever we're adding and adding it to the variable and assigning it to itself again. All these operators work the same. So plus equals is going to add, minus equals is going to subtract, star equals is going to multiply, divide, the slash equals is divide. So it's going to divide the one value away from the other. The remainder equals, same thing. This is square root. And then we have the ability to square. So if we go back to our example, we can actually change this running total to look like this. Much simpler, right? There you go. Okay, now we're going to talk about another concept called sentinels. Anyone catch the term sentinel, where that may, but well, a pretty famous movie used the word sentinels. Yep, slightly different, but always whenever I see this phrase, it reminds me of the Matrix. Like I said, it is different. The context is different, but again, homonyms. All right, so sentinel, a special value that marks the end of a sequence of items. That is fancy talk for saying that some way we want to flag the end of something. So I took what was fancy and made it sound like nothing, right? So for example, if we're reading the input of a file, we need to know when we come to the input of the file. Or what if we're just reading in data from something, whether it be a file, a database, or the user? We want to somehow signify that we've come to the end. So one way we can do that is what we're going to do in our homework, and what we've kind of done already with the yes or no code that we previously had, is we're going to, if the user types yes, we're going to keep going. If they type in, we're going to stop. Well, that flag is known as a sentinel. Another common sentinel is when you're typing, when you're dealing with a console app like we've been writing. If you hit just the enter to an input field, then nothing goes back to the data side or to the application, and that is a clue or a sentinel to say stop asking for input. I wonder how far back we can go. Z it all the way. Oh, no. Okay. So here's an example of our sentinel. The Y or N is our signal. We're going to keep going until we get something other than Y. Once we get something other than Y, it's been signaled to us that we are at the end of our input of data. Now, another way of doing it oftentimes is to say enter to stop. Well, enter to stop means that instead of putting a value in, they're going to actually put in just an enter. To check for that, we're going to check for what's known as an empty string, which is just two single quotes together. And now we know that that is empty string. So again, if we run this, oh, we found out what was wrong with this before, right? Yeah. So it was 25,000, and we get a commission of 2%. And again, if I type anything at all, sorry, forgot to put this as equals. Try that again. So here we go, 25,000, 2%, it's 500. If I type anything and hit enter, we can keep going. When we hit enter, it stops, because what goes back to our program is a sentinel, and that is the empty string, because all we did was hit enter. Any questions about that? All right. This is one of the more common, especially when we're dealing with console apps, use of utilizing loops, and that is the input validation loop. So we want to check as clients enter, or users enter data into our program, that it's has value, that it's not corrupt data, it's not bad data. You'll hear a lot of times this idea of garbage in is garbage out. And it's like taking a picture. If the picture's fuzzy, you can't fix that. There's no way of going back and fixing it. You can take a really well taken photo and make it fuzzy, but you can't take a fuzzy photo and make it good. So garbage in, garbage out. You can't make stuff up along the way. So if you ask your user for a number and they give you the letter A, there's not much you can do with that. So instead, what we can do is we can set up a loop that is going to essentially ask the user for some information. We're going to then test that information that they've entered for qualification that it's the right type of data, it's the exact piece of data we want. And if they didn't give us that, then we just start the loop again and re-ask them the question. So with that being said, we can use these loops to do that, and it's called an input validation loop. So we want to inspect input before it's processed by the program. Again, if you're taking in two pieces of information from a user that you want to multiply together, if they, in one of those pieces of information, say a letter, then we have a problem. Remember back in one of the homework assignments, we asked for you to give us a positive difference between two numbers. Well, a lot of you chose just to go to kind of a very standard route, which I was okay with, where you just expected the first number they were going to enter was going to be the bigger of the two numbers. And then when they typed in the second number, you could have used a loop here to compare those numbers and see if the second number they typed in was bigger than the first, to ask again, like, hey, nope, you gotta give me the a smaller number, right? And you just sit in the loop until they finally give you a smaller number. So that's what we're going to do here. So far, we have said, we're going to say this user input, keep going, enter to stop. Well, let's go ahead and say 1 to keep going, 2 to stop, okay? Well, now we want to make sure that it's a 1 or a 2. So one way we can do that is we're going to say, set up a variable. We're going to say true because we're going to prime the loop. And then we're going to say while, I'm sorry. We want to say that's false because we expect that the data, we want to prime the loop to get the condition going, and the condition is going to keep going if the data is bad. Okay, so we're going to say while got good input equals false. So we're going to ask the question now in the loop. And then we're going to test that piece of information. We're going to say if user input equals 1 or user input equals 2, then the input that's coming in is good, correct? So we can now say user input equals true, which is going to stop our loop because we're looking for false. So now that they've done something good, we set that as true. The user got good input. Sorry, got good input is true. So that's going to break us out of this while loop. If I type 3, it's not going to go and change the got good input to true. So it's going to go back up and it's going to ask me again, do you want to keep going? Let's see that in work. Enter sales, 25,000 at 5%. Sorry. Multiple languages. Now, if I type 3, it didn't recognize that as valid input. And so it literally will keep going until I type 1 to keep going or 2 to stop. Now, why is it not stopping? Because our if statement is looking for a numeric value, but our input isn't returning a numeric value, it's returning a string. So we got to make sure, because it's returning a string, we either have to convert the string into an int or make us compare it to that. By the way, if you get into an infinite loop like that, like I did, then Control C will break you out of it. So that keeps us in the loop, but 2 will stop us. Now, again, this didn't work correctly because we also forgot to change our if our user input equals one. Now, even though they have to type a 1 or a 2, we still only have to check for one of the values because we're expecting only one or the other. So if it's not the 1, which is actually we want 2. If it's a 2, then we're going to stop. We're going to change our signal to 0, which is going to then cause the loop up here to stop. So 3, we'll stay in this loop, keep asking. If we hit 1, we should continue to keep going. But if we hit 2, we should stop. So this is just an example of a flow chart that talks about what we just did, which is, we're going to get input. We're going to check to see if the input is bad. We're going to display an error message and then get the input again. That was the one thing we didn't really do, which was to say, so we can go else must enter a 1 or 2. And then we'll put a 3 in. Oh, it didn't do it. Okay. Did I do something that silly? Yes. Thank you. It is 7:40, by the way. Been up since 6 this morning. Let's try that again. Oh, so there we go. Must enter a 1 or 2. All right, good. Okay, now the fun part. It's all fun, but this is the part that I like to talk about. We're gonna talk about nested loops. A nested loop is nothing more than a loop within a loop. Whether it's a while loop on the outside and a for loop on the inside, or a for loop and a for loop, a for loop and a while loop and a while loop. As long as there is a loop that is inside another loop, you have a nested loop. Their example is a clock. So you would enter into one outer loop for the hours and then an inner loop for the minutes, because you want to do 60 inner loops for every one outer loop, which is the hour. So 60 iterations for the minutes, and then we would do one iteration per 60 for the hour. This is what that looks like in a diagram. And as you can see, we have several diamonds in here. So as we have diamonds, those are conditions. The last two are actual conditions for a loop. Now, with that said, we try to avoid nested loops as much as possible. And the reason being is, more than likely, if you go down the route of becoming a programmer and going through a degree for programming, you're going to at some point get into what's known as time notation when it comes to programming. And one of them is known as the big O. That's bad time. That means it's going to be infinitely long, and it gets longer exponentially as you add to it. Now, for example, if we go and we have a piece of code and we say for count 1 in range from 0 to 100, step 1. Then we have, and we print count 1. Then we say for count 2 in range 0 to 100, 1. Okay. So let's run that. See how long it's taking? And that's because for every one of these loops, 100 of these loops have to happen. So let's imagine that each one of these loops takes a second. So what you have is, you have in math, you have 100 seconds for the inner loop. And for each inner loop, you have a second of the outer loop. So that means we are actually, I'm using notation that's Python notation. So it's literally 100 squared by 100. Because for every 100 of these, one of these will happen. So for 100 of these means that 100 of these will happen for every one of these, which means this loop is going to go 100 times and do 100 iterations itself. Make sense? So that's why what happens is each time the inner iteration is squared by the outer iteration. So let's change that up a little bit. So let's just say that this is only going to do it 10 times. So the math on this is 100 raised to the 10th power. And again, imagine that these were seconds. It took a little bit of time, right? We've already seen if I take this up to 100, it's even worse. So what? Let's really keep it simple. Let's take both of them down to 10. And now we have 10 to the 10 power. Fairly quickly, right? Now, let's do this. Or count 3 in range. So now we have this map. 10, that's raised to the 10th power, and that result is then raised again to the 10th power. You see how that's why that big O notation is every time you add another for loop, you exponentially make your code run longer. I can tell you right now, in my organization, you're not allowed to have a loop that is 3 deep. 2 is the deepest level of looping you can nest. Because again, you're just asking for trouble when you start looping inside of looping inside of looping. I have come across code where there were 6 inner loops. And I don't even go any further. I don't care how fast the inner loops are working. It's raised 6 times exponentially. It's not going to go fast. So we would reject that right away. So again, here's that piece, which was relatively quick before. See, we're exponentially bigger, longer. They're still going, and we've only done 10 on each loop. So that's why we have to be careful when it comes to nested loops. So with that being said, you may be asked to create a nested loop. I know for a fact that you have to do one assignment that is too deep. If you come across an assignment that is asking for a 3 or 4, do the assignment. I don't think you are asked of that, for the educational purposes, do what you're asked to do. Just know that in standard organization in the industry, it's a bad practice to have nested loops. You definitely don't want to go really more deep than 2. Okay. This talks a little bit about that. It doesn't really go into the time aspect of it, but interloop goes through all the iterations each time for every outer iteration. So that is where we're at with the assignment. Let's talk a little bit about the homework. So in program 4.1, we are asked to read my notes here, to ask a user for input. And if that user inputs something that's even, we're going to keep a running total of how many times the user puts an even number in versus an odd number. Okay, So definitely some of the things that you have to think about. Here's our def main. So we are going to var for, and let's go ahead and type out some pseudocode. Var for incoming user input. Var to keep running total for evens. A var to keep running total for odds. Then we're going to go ahead and start a loop for user input. The test being user input isn't enter and is positive. Now, one of the interesting things about the instructions for this program is it does say that you should be looking for user input that isn't enter, right? Because enter means stop, and that it's a positive number. So if the user were to type in a negative number, I would expect that we want to stop the program. Now we're going to get the user input. And we want to check to see that the amount entered isn't enter and is greater than 0, right? Because 0 doesn't really add much value to this. And by the way, there is a long running mathematical argument of whether 0 is even or odd. If you want a good read, Google that. Is 0 even or odd? Most people consider 0 to be even, just FYI, but not everybody. Because right now in our current world, 0 is neither, we're going to say everything that's greater than 0. So let's not do that. Is the input even? Increase even emulator. Else increase odd emulator. Okay. By the way, just FYI, YouTube hates when I talk that way because it doesn't know how to create captions for my very long words. And I'm like, accumulate, because I'm saying it as I type it. It cracks me up. So I try to remember not to do that. I try to remember to type the code and then say it in one quick sentence. So that way YouTube can create the captions for me and I don't have to go back and manually edit them. Just a little bit of tidbit, things you learn along the way. All right. Now, nope. And once we've done that, we are going to output the totals. How's that look for good pseudocode? So pretty simple. We're going to say user input. We'll assign it 1. You'll see why we're doing 1 here in a moment, because we are priming the loop that we're going to be creating here soon. We are building up our accumulators. When we start out our accumulators, most of the time we want to start them at 0. Not always. If you're writing, let's say, a check writing program, a lot of times people don't want their checks to start at 0 or 1. They want to start at 1200 or something odd like that. So in that case, your accumulator would start at a higher number. You can start an accumulator at a higher number if that makes sense. Right. Now, what is our for loop going to look like? Assuming not our for loop, our while loop. Because we want to create a while loop that's going to sit in the loop while we're asking user for input. And remember, we just primed the loop. So part of this is we also know that the user input the first time in is going to be 1. Now, do you guys remember we talked about shortcutting conditional statements? So depending on whether it's and or, the very first item in a conditional statement will dictate whether the application or whether the code will even look at the rest of the conditions, right? So in this case, we're going to say user input is not equal to that blank and int user input is greater than 0. This is an extremely important reason why you have to understand that shortcutting or the short wiring of a conditional statement. So what we have going on here is the notion that when we ask the user for input, they have the option of putting in an enter, which means it's going to come back as a string, a blank string, an empty string, I should say, not a blank string, an empty string, or it can come back as something that could be a number, right? So we cannot create a while, we cannot compare, or in this case, see how we're taking the user input and we're converting it to int? If we tried to convert a blank string or an empty string like this to an int, our program would actually throw an error. So what we do is we first check to see if it's the blank string. If it's not the blank, if it is a blank string, or in this case, because we're using the is not, if this evaluates to true, true. Sorry, let me try that again. If this evaluates to false, right? We know that there's no way an and statement can work because they all have to be true. Agreed? So if this very first thing comes out to be false, it will never even try to run this next part. And that's important because if it's an empty string like this and it tries to go into this int conversion, it will throw an error. Okay? So we want to make sure that if it happens to be a blank string, it won't even try to run this anymore. It will stop and just go ahead and continue to do the while statement. Does that make sense? If it was backwards, and the user were to enter an enter, because it would come back as a blank string and it would run this first, it would throw the error. So that's where that short circuiting of your conditional statements works to your benefit. All right, so we're gonna say if the user input's not that and the user input is greater than this. So again, it needs to be not this, true, and it needs to be greater than this, true, means we can continue in doing the while loop. Otherwise, if they hit enter, that means it's going to come back as a blank statement. This is going to be false, and it's going to come out of that loop. Everyone follow on? Okay, so now let's get the user input. So the user input sorry. Looking at my code here. Equals input Next thing, notice how I'm not putting this and wrapping this input with an int statement. Again, if I were to do that and they were to hit enter, we're going to get an error because it cannot convert an empty string to an integer. So I have to just let them enter their input in first. And with that being said, now I can check things. Now, again, because we just got user input, I do need to verify that they haven't entered one of these items, whether it be a enter or a negative number, before I run my next set of code. Because if they've done either of those things, then I shouldn't run my code. That makes sense? So, for example, if they hit enter, then I don't want to increment the even or odd accumulator anymore. If they give me a negative number, again, I don't want to increment the even or odd calculator anymore. So that's why I do that quick check. Now that I'm here, and now that I've done this, I know that since it's made it through the statement, we know that it's not a empty string and that it should be an integer. So now I can go ahead and just make things life a little bit easier. I'm going to go ahead and say user input equals int user input. So I'm taking what is a string in user input. Because remember, even if they entered a number in, we haven't converted it yet, so it's still a string. So I'm now taking that and converting it to an int and just literally reassigning it back to the same variable. Now I've just taken what was a string and made it into an actual integer. And because I've done that, now it makes my if statements a little bit easier. If the user input remainder 2 equals 0, then we're going to say even total, and we're going to use our shorthand plus equals 1. Else, because it's either one or the other, odd total plus equals 1. I'm going to remember what I told you at the beginning of the class. I like to have a lot of white space in my code. So that's what I'm doing right now is I'm just making sure I've got some white space in here to help it breathe a little bit. So it's a little easier to read, at least in my mind it is. And now it's time for us to go ahead because now we've iterated through this. We kept on going until the user hit either enter or gave us a negative number. Now we've broken out of that while loop. Let's go ahead and print the information. And we'll make bets it runs the first time. Enter a positive integer or enter to quit. 5. That's complaining about line 32. Yeah, it doesn't like that. Line 27, because I spelled that wrong. So what I did was, in a traceback, the errors go backwards, right? So what this is saying is that there was an error at line 32. Well, I go back to line 32, and that's my main. And that's because this was the outermost piece of code. We go down to the next one, and now we're getting a little closer because that is the error that occurred inside of main. And it was that issue where I misspelled that word. If there was another error below that, then that means that we've called into another function, and that error is within that function. I don't know what I just did there. Five, 2, 4, 7, and we hit enter. And we have the evens total 2 and the odds total 2. Let's do another test because we kind of did a happy path test there. Let's do 1, 2, 3, 4, 5, which means we should have a different number. We have two evens and 3 odds. Any questions about this? Now, I'm going to tell you, I just gave you the solution for the first one. I would strongly recommend putting this away, doing it on your own, and only pulling this out if you are running into some problems, because this is an essential part of programming. And it's things you're going to be doing in the next chapters as well. You'll utilize this a lot. And so if you don't have a full grasp or understanding of this on your own, you're going to just struggle. So I would get your struggle out of the way now. Make sure you understand this by actually doing it yourself. And then if you have problems, like I said, refer back to what we've got here. By the way, yes, I remember my professor saying that, and I didn't always follow, but I'm just telling you, it'll make your life a little easier the rest of the semester. Before we go on, a couple of things. So we do have some challenges here that we overcame. We wanted to create that loop for the user input. And we wanted to make sure that we use the Sentinel to stop for the user input. But the challenge we were going to have there is that we need to check for both that enter press and the fact that it has to be a positive number. Because one's a string and one's a number, we had to be able to be a little bit flexible in our while statement and our if statements. Now, one thing to be thoughtful about is, again, we really did state or made our code function that either we are really expecting that they're going to enter an enter or some kind of number. What if they don't? What if they enter the letter A? They just got an error because I wasn't expecting that piece of information. So what we were doing before is known as happy path testing. I was definitely entering in data that I knew the application was expecting. This type of testing isn't happy path testing because I entered in something that the application may not be expecting. And sure enough, I got an error. And so that's the problem. So something to think about as you're going forward is, as a developer, we want to try to make our stuff bulletproof. One of the biggest places that we find problems is where we allow user input. Are we testing for user input, and are we testing, all the conditions that could be there? All right, now we can go on to the next program, which is for 2. I don't want to get too into the homework on this one. I want to make sure you guys have something that you can work on and challenge yourself with. The things to know off the top of your head is you are going to want to set up a constant value. Remember, constants are variables that are in all caps. This is a constant you're going to want to know, which is the number you have to multiply against an inch to get its centimeters. That was an easy Google search. You're going to ask for 3 inputs that are later used as parameters in your range, your call to the range function. You are going to utilize formatting. I'll give you the first one, which is the header column. Excuse me, the header row. Right? So you're going to say print. Now, because we want to actually give it a word to output and not a variable, we're going to go inches in double quotes. And this particular column is supposed to be 8 characters wide and formatted to the left. And then the next word we want is and that is 12, but it's centered. Now, when you go to actually output the rows of data, that's a good start on the formatting, but there is additional formatting that you need to add to the numeric rows going forward. And then the next thing you must know is that your for loop is going to have a target variable with range as your function that will create the iteration behind the scenes. So again, you're going to have 3 variables that you're going to pick up: the start, the end, and the step. And you're going to use that in your range for 4. Make sure you put your colon on the back end and then use inches, your target variable, to times it by the inch to get your your centimeters value, but you need to do something with this, what I just typed. This is not the complete line. That's all I have to say about that. And then finally, for your third piece of homework, you are going to ask the user for how many rows. You're going to take that variable. You're going to make one for loop. And we want the stop number, right? So we're going to just do we only need to know where to stop. We can start at the same number, which is 0 always. So we only need to use one parameter in our for loop. And then we need to create our nested loop. Also only needs the one parameter. But here's the trick. We need to, because if you use print here, you're going to get the numbers going top to bottom. You're not going to actually get rows of data, right? So you need to use string. You're going to concat strings into a variable. And then at the outer, going back to the outer loop, we're going to make sure I get this right. Yep, for the outer loop, now you're going to want to print your concat string. Make sense? Yeah, so one of the questions is, do we need to create a validation loop in the prep program? No, you can assume, because the instructions don't actually ask you to create an input loop, an input validation loop, you don't, if it doesn't ask you to specifically do an input validation loop, you don't have to. All right. Any questions? Any concerns? So why don't we do this? I'm going to stop talking and we'll hang out here for 15 minutes. You're more than welcome to sit here and do some programming, and I'm here to answer questions. Or you're more than welcome to go ahead and leave or drop off the call. In fact, we're going to probably stop the recording, but we'll stay on the call. So if anyone has questions, we can go ahead and answer them. And like I said, we'll stay for about another 15 minutes and then call it a night. All right. Let me stop the share.